All right, y'all. So like I said, 9.6, solving exponential and logarithmic equations. So first we're going to start out solving exponential equations. All right, y'all. So exponential equations look like this. A to the x equals y. So the variables up there in that exponent, okay? So what helps us in this section is what we call the base exponent property. Okay, so the base exponent property says if a to the x equals a to the y, so you got two bases that are identical on either side of the equal sign. Well, remember, if these are equal and the bases are the same, then that means that the exponents have to be equal. So if a to the x equals a to the y, then x equals y. Okay, so sometimes to solve exponential, we try to rewrite them where they got the same base. That way we can set the exponents together equal, okay? So let me actually give you the steps to solving exponential equations. All right, so the first thing I want to look at, can I rewrite each side using the same base? So can we rewrite each side using the same base? All right, so that's either yes or no. If yes, so say I can rewrite both sides using the same base, then set the exponents equal. Right, that's what we said here. If the bases are the same, then I can set the exponents equal to each other. Then solve for the variable. So they're pretty quick if you can actually rewrite each side using the same base. But if we can't, rewrite each side, then we have to solve it doing the following steps. Because remember, since these variables are up here as exponents, I need to bring them down so that I can solve for that variable. So the way we bring an exponent down is by using the log of each side. So if I can't rewrite each side, I'm going to take the log or the ln of each side. All right, so once I take the log of each side, I'm going to have something like this. Log a to x, y. Remember, if I got a log, I can use the power rule and bring that exponent down to the front so that I get log y times log a of x. That's the power rule we learned the other day. So to solve for a exponent, you got to bring that exponent down by taking logs of each side. So I did that right here. Now, bring the exponent down using the power rule. And, that's what I'm doing right here. I'm bringing my exponent down using the power rule. At that point, I'm going to solve for the variable. Now, when you have to solve them by taking logs or LNs, we need to round our answer 4 decimal places. All right, then the last step on any equation, check your answer. All right, so those are what's going to happen. I'm either going to be able to rewrite them using the same base, or I'm going to take logs or LNs of each side. So what I'll tell you, I'll use a log every time unless they're using the little e in the problems. If they use the little e, I'm going to take the ln of each side, okay? All right, so the best thing to do, y'all, is start solving these equations. Now remember, all those rules we looked at on Tuesday night are in play, okay? But you'll see them mostly when we get to the log equations. So let's start out. These are going to say solve for x. So number 1, I got 2 to the x equals 32. So the question is, can I rewrite 32 using 2 as its base? So can I multiply 2 times itself a certain amount of times and equal 32? Well, let's try that. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I did that 5 times. So I can rewrite 32 as 2 to the 5th. So you can take the base and just keep multiplying it. And if it does equal that number, then it's able to be rewritten. So watch this. I'm going to bring down this 2 to the x. I just rewrote 32 as 2 to the 5th power. Okay, remember that exponent tells me how many times that 2 got multiplied to make that 32, right? But look here, my bases match up. So since the bases match, that means the exponents are equal. So y'all, that means x has to equal 5. So if I check it and put a 5 in for the x, 2 to the 5th power equals 32 is a true statement, okay? All right, y'all, so we're doing the same thing. Let's see what y'all think on this one. I got 6 to the 4x. That's going to equal 216. So the question for y'all, can I rewrite 216 as 6 raised to an exponent? Since 6 is the base on this side, I want to rewrite this side using the same base of a 6. So will 6 multiply and get me a 216? And if it does, tell me how many times I need to put for my exponent. All right, y'all, chat's already going. Let's see. All right, Vinny, good job. 3 times. So we're going to rewrite 216 as 6 to the third power. Okay, y'all, because 6 times 6 was 36, times that other 6 equals 216. So now we got 6 to the 4x equals 6 to the third. All right, y'all, good job, y'all, because now the bases match. So the 4x is going to equal the 3. All right, so this one has a little bit more work than I had up here because my x had some numbers by it. But at this point, I'm just going to divide by 4 and be done. All right, so we got 3 divided by 4. So that cancels, giving me my 1x. And then what do we got? 3/4. We can't reduce that, so that's going to equal 3/4. So if you put the 3/4 in here, the 4s would cancel, and 6 to the third would equal 216. All right, y'all, so those first two were nice. They was able to be rewritten using the same base. So let's play with a couple where we might not be able to rewrite them, okay? And these ones will start at number 3 for us. Now they're still exponential equations. So number 3, I got 2 to the x equals 23. Alrighty, so we know we can't rewrite 23 using a 2, right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's too big. So we can't rewrite this one. So remember, we said if we can't rewrite them using the same base, I'm going to take a log of both sides. So what that means, we want to take the log of 2x. That's going to equal the log of the right side, which is a log of 23. And y'all, the reason we took the logs, remember, is because now using the power rule, I can bring my exponent down to the front. So using the power rule, bring the exponent down. So that'll give me a x times log of 2 equals a log of 23. All right, so I got x times log 2 equals log 23. At this time, I'm going to divide both sides by log 2. That'll get my x there all by itself. Because on the left side, those logs are going to cancel. And over here, I got a log of 23 divided by a log of 2. Now remember, I said if you got to take logs of both sides, we need to round our answer 4 decimal places. So y'all watch this. Those cancel. I'm left with x. And since we're rounding 4 decimal places, we're technically approximating our answer. But here's the thing on this. When you punch this in the calculator, we need to close those parentheses on top before we hit the divide, and then put in our log 2 and close those parentheses. Okay? So you got to close parentheses on the logs before you hit the divide. So I'm going to share my calculator and see what we get. So y'all, logs right on the front. So I had a log of 23. See how it opens one parentheses, then you're going to close it. Oh, Viddy, you're so close, but go out one more decimal place. Because you're 3 decimal places with that 524. So take me out one more space, okay? All right, now and then what I have on the bottom, log of 2. All right, Biddy, I was going to let you write your new answer before I hit enter. All right, y'all, let me see what I get up here. All right, so let's see. 4 decimal places will be the 5, but the 5 has a 6 after it. So we're going to round the 5 up to a 6. So Viddy, you're perfect now. 4.5236. So 4.5236. So y'all remember when you're rounding 4 decimal places, you got to look at the 5th one to see what you do, okay? All righty. Let's look at number 4 here. 2 to the 7x minus 1 equals 16. So can we rewrite 16 with a base 2? And if you can, what's your exponent? So I can do it 4 times, right? 2 times 2. So we're going to rewrite 16 as 2 to the 4th. Good job. All right, so it brings down my 2 to the 7x minus 1 equals 2 to the 4th. Now, y'all notice we did get the bases to match. So our 7x minus 1 on this exponent has to equal that exponent of a 4. All right, y'all, let's see. Looks like we get a 5/7. So I would just ask you one question. Okay, so you added 1 first, it looks like. And you got 7x equal to my 5. Good job. And then you divided by 7. And that gave us a 5/7. Good job. Because those 7's cancel and x equals 5/7. So really, they're not too bad if you can do this rewriting. And the only trouble on these ones are that you're having to do that rounding off, okay? All right, y'all, how about this? 3 to the x equals 8. So can I rewrite both sides of this with a base of 3? And if so, what's its exponent? All right, y'all. So no one's answering that one. So apparently we can't rewrite this one because 3 times 3 is 9. That's already too big. So I can't rewrite this one. So since I can't rewrite it, we're going to bring the exponent down by taking logs of both sides. So you're going to do a log 3 to the x equals a log of 8. Then we're going to do the same thing up here. We're going to use the power rule and bring the exponent down. So I'm going to bring that exponent down so that I get an x times log 3 equals a log 8. And you'll notice it's the same process as that once you got them brought out. I'm going to divide both sides by the log 3. That's going to equal log 8 divided by log 3. Once again, put them in parentheses, remember, so that those will cancel in our x. So let's see. 8928. All right, I got 2 of them saying 1.8928, so I'm going to assume that equals 1.8928. And y'all, let me show you. All they did was they went on that calculator and they did a log of 8. So log of 8, close parentheses, and we divided that by our log of 3. Close parentheses. And y'all doing good because a lot of these are rounding up actually that I've noticed, okay? So 1.8928. Good job. All right, let's see what 6 is. 6, I got 10 to the negative x equals 4 to the 5x. Now, I'm not going to lie. You're going to get the same answer on number 6 that I did when you got an equation like this. And I'll show you what that answer is when I get to it. But you're going to get the same answer I do on number 6. So the first thing, I'm not even going to try to rewrite that using the same base. So I can't rewrite it. So remember, since we can't rewrite it, we're going to take logs of both sides. So I get a log of 10 to the negative x will equal a log of 4 to the 5x. Now, y'all remember, the reason we did that now, what's my next move? Bring exponents down. Good job. So both sides, we're going to bring these exponents down so that I get a negative x log 10. That's going to equal a 5x log 4. So y'all, let me tell you what the situation is now. I got an x here, and I got an x over here. I need to get my x's on the same side. So at this point, we want to get the x's on the same side. Now, what I do, since this one's usually negative, I add this to both sides. So what I do is I'm going to add x log 10 to both sides. So guess what? This side, negative x log 10, positive x log 10, that's going to cancel, making that side equal 0. And y'all, when y'all are working it and you get them on the same side, you're going to get a 0 on one side, okay? Now these aren't like terms, so I got a 5x log 4 plus x log 10. So I wonder, how can I get these x's to be just a single x? So it's sort of like when we were factoring before. What do they both got in common? They both have an x in common. So at this point, factor out the x. So I'll have a 0 here. So since they both have an x in them, I'm going to factor out that x. And y'all, guess what? In parentheses, I'll have a 5 log 4 plus a log 10. All right, now look at this. This x is being multiplied by the parentheses. So we're going to divide both sides by the parentheses. So this is still a 0 divided by the parentheses. 5 log 4 plus log 10. That'll equal the right side. X times 5 log 4 plus the log 10 divided by the 5 log 4 plus log 10. So notice the right side, all those numbers numbers cancel. All that's left is our x. So y'all, no matter what you're dividing by, this side is a 0 divided by anything. Well, 0 divided by anything is a big 0. And y'all look here. When you got different bases, 0 is the only exponent that can make this one be equal. Because 10 to the 0 is 1. 4 to the 0 is 1. So be careful on that, but you should get that answer on that one, okay? So that's one of the trickier ones, and it's just because you had to get these all on the same side so you could factor out that x, okay? All right, so y'all was at 6. All right, so they start toning down a little bit. So number 7. E to the t equals 525. Now, don't that make you want to say phone home? Now, remember, when I had those steps, I said if it had a little e, I'm not taking logs. I'm going to take the ln of both sides. So take ln both sides. Since we have that little e, okay? Because y'all watch this. ln of e to the t equals the ln of 525. Well, y'all, here's something you got to recall for this one. And this would have came from section 9.3. But the ln of e to any exponent is the exponent. Because remember, ln is really a log base e. So you got a base that matches the base of the result to an exponent. We always said that equals the exponent. So the left side, you can bring the t down, but it don't matter because ln of e to the t equals t. It equals whatever the exponent is. Now the right side, we got to figure out what is the ln of 525. So y'all punch that in and round me out 4 decimal places. And let me see what y'all get. So if I get 2, y'all just got the same answer. I'm going to assume y'all are right, okay? Oh, Samantha, you were really close. There you go. That's what I want. 6.2634. There you go. That's perfect. Always remember to round them up if you got to. All right, y'all. So number 8, e to the negative 0.50t is going to equal 0.30. So it's got the e again, so I'm going to take an ln of both sides. Because I know that ln on this side will get rid of everything but that exponent, okay? So we're going to have ln e negative 0.50t will equal to ln of a 0.30. All right, y'all, so I'm using that again so that this left side is going to equal negative 0.50t. Now, since I got more work to do, I'm not going to evaluate that yet. I'm going to leave that at ln 0.30. You always want to do the LNs on your last step for your accuracy, okay? Because no, I got to do something to get this t to be a 1t. I got to now divide both sides by that negative 0.50. And that'll equal the ln of my 0.30 divided by a negative 0.50. So once again, remember in the calculator, put that in parentheses. So y'all try that one and let's see what you get. Because that's going to be a t on this side. So we're going to approximate that 4 decimal places, okay? So what do we got? ln 0.30. Close my parentheses. And then that was what? Divided by a negative 0.50. Now, what you got to remember, don't do the ln on the bottom because that was just a negative 0.50. It didn't have an ln with it, okay? So when I did that one, I'm getting around a 2.40794. So I'm going to leave that as 79. So Samantha, you're perfect. Good job. All right, so the last one of the exponentials, and I don't really care for this one either, but they got it in there. 12 to the x equals 4 to the x plus 2. So y'all, once again, I can't rewrite those. So I'm going to take a log of both sides. So I'll have a log 12 to the x equals a log of 4 to the x plus 2. So this will probably be one of the longest, well, it will be the longest one for the exponential, okay? So remember, next, I'm going to bring the exponents down. So this side, you're going to get an x log 12 equals, now y'all, here's the thing. When you bring this exponent down, that x plus 2, since you got two terms, the x plus 2 has to be in parentheses times the log 4. Because if you don't put parentheses, it'll only do 2 log 4. So remember, this whole exponent is affected by the log. So my next step, I'm going to bring down this x log 12. Over here, you're going to distribute both of these times that log 4. So you're going to get an x log 4 plus a 2 log 4. All righty, so just remember, both of these have to have the log 4 with them when you get it all written out. Now remember, we're solving this for x. So I need all these x's on the same side. So what we're going to do now is subtract the x log 4 from both sides. Oh, y'all fun already, right? So these are not like terms. So you got an x log 12 minus the x log 4. But y'all look here on the right side, those canceled. So all that's left on the right side is a 2 log 4. So how about this? I got x's in both places. I need to make that a single x. So if you remember while ago, at this point on the left side, I'm going to factor out the x. Y'all remember, if you got x's in two terms and they're not like terms, The only way to make that a single x is by doing that factoring out the x stuff, okay? Because look here, I'm going to factor out the x. In parentheses, that's going to leave me a log 12 minus the log 4. All that's equal to the 2 log 4. And then remember, last time I had x times parentheses, I divided both sides by the parentheses. Now, the reason these look like big problems is because these logs, we can't evaluate them into single numbers until the end, or you'll lose accuracy. So that's why they seem longer, because we got all these logs running everywhere. All right, y'all, so a 2 log 4 divided by log 12 minus log 4. So look, those cancel. I got my x. Now let me show you how I'm going to do this one. I'm actually going to make this one look like a fraction. And remember, to make it look like a fraction in the calculator, I'm going to hit alpha y equals. And then it should say ND is my choice I'm going to pick, okay? That's how you get them into fractions. So let me show you how I'll put this one in. I'm going to clear that off. So I'm going to hit alpha y equals and enter to get the n over d. On top, we had a 2 log 4. So that'll be 2 log 4, close parentheses. On bottom, I had a log 12 minus log 4. So I got a log 12, close parentheses, minus a log 4. And y'all, that looks just like it was on my paper. So let me see. Is that an answer to this one, Viddy? That 2.5237? So when I hit enter, oh, you're getting good then, because I got what, a 2.5237. So y'all just be careful on that one so that you get it set up right. I would recommend the alpha y equals, okay? So that is the world of the exponential. So now we're going to look at logarithmic equations. So number 2 here, like I said, what I say, solving logarithmic equations. So remember, those will be like a log base A of x equals y. So they got them logs in them, okay? So this is where all them log rules the other day come in play. I had a product rule, I had a quotient rule, and I had my power rule, okay? So let me write them up here real quick. Log base A of x times y equaled log base A of x plus log base A of y. I'll rewrite products as a sum. If I had log base A of x to the y, this was the power rule that we're bringing the y down and getting y times log A of x. And then finally, we had a quotient rule, log A of x divided by y. Remember, quotients were rewritten as differences. So this will be log A of x minus log A of y. So y'all, these are still in play. Those are going to help me solve these. Now, what's nice, remember I had that base exponent property where I tried to rewrite them using the same base. I got what we call a log base property. And it's really, really similar to the base exponent property. This one says if log base A of x equals log base A of y. So I got a log equal to a log. They got the same base. If that happens, then the results are equal. X equals y. So I try to rewrite them like this because that's the easiest way. If not, I'll show you what I'm going to do. So here are the steps to solving logarithmic. So here's the first thing you got to do. If you got more than one log on either side of the equals, you got to combine the logs. So combine logs if needed. On either side of the equals. So they got to be on the same side. If they do, then I'm going to do this stuff. If they're being added, I'll rewrite them as a single product. If they're being subtracted, I'll rewrite them as a single quotient, okay? All right, so after that happens, do we have a log base equal log base? So that's looking at this property. If yes, then set the results equal to each other. Because y'all remember, this x and y up here, those are the results. The bases are the a, okay? So set the results equal to each other, then solve for that variable. If no, so if I do not have a log base equal to a base, so if no log base equal to a log base, then I'm going to rewrite it as exponential. So exponential was, remember when I took the base, the exponent, and equaled it to that result. So we're going to rewrite them as exponential like y'all did the other day. Remember, once I got it written as exponential, I'm going to solve it for that variable. Now, on a log, check this out. You need to check answers on logs. Okay, because remember, check answers, because we cannot take logs of negative numbers. Okay, you also remember the other day when we tried to take logs of negative numbers, it gave us an error message. So we'll put the solution is not a real number, okay? And let's see, they give you a choice B on that, but usually on these you'll get a positive answer and a negative answer. So you only can keep the positive answers, okay? Because you're going to get two answers on a lot of these. All righty, so I guess we're ready. These are going to say solve for x. And these start at number 10, okay? So log base 2 of x equals 4. So I've already got a single log over here, but there's not a log on this side. So I can't do the log base equals log base because I don't even have a log over here. So since I got a single log equal to a number on this one, I'm going to rewrite as exponential. So your base is 2, so bring down to 2. Exponent is the 4, remember, because the log finds the exponent. That's how you remember that that's the exponent. And 2 to the 4th has to equal x. All right, y'all, so the question would be, what is 2 to the 4th equal? Because that's all we got to figure on this one. That's going to equal my x, so let me see what chat gets on 2 to the 4th. What am I seeing? 16, there you go. So 2 times 2 times 2 times 2 is 16. So I'm good to go. Next question. So you'll like some of these. These ones go sort of quick at times if it's written like that. But you know they're going to increase them as we go, right? Where they give us more steps to do and stuff. All right, so let me move this out of my way so I can see to move my camera up. All right. So 11, I got a log x equals -4. So guess what? I got a single log already. I don't have a log on this one. So since I got a single log equal to a number, I'm going to rewrite as exponential. Uh-oh. I don't have a base here. So refresh me on what my base is. All right, Nancy, good job. It is definitely a 10. Remember, if there's not a base shown, it's a 10. So that means 10 to the -4th equals that result of an x. All right, now I think MathLab wants us to put this in as a decimal. So let me go see how they want it. I think they want that in as a decimal. So I'm going to share my calculator. And let's see, we got what? 10 arrow. What was that? -4. Okay, it puts them in. Let me see if it'll do it in decimal form over here. So I'm going to go to number 2 and hit enter. Enter. All right, it keeps it as e to the -4. So let me show you what you got to do to that. I didn't know if the calculator would do it or not. But so 10 to the -4, say you got a 10 here. That -4 means you're going to move the decimal left 4 times. So that'll be 1.0, then move it up, add zeros as needed, so that I get a 0.001 basically, okay? So 0.001 will equal my x. So let me see what the calculator does to that. 0.001. Oh, now it leaves it like that. So, oh, it's going to kill me. But yeah, that's what you got to do on that, and is just sort of move that decimal left 4, because I don't think MathLab will take it as 10 to the -4th. I can't remember. Oh, I think I need to move it left one more time. I think you start with 1. My bad. Because this is like 1 times 10 to the 4th. So move it from 1 back. And it should be 0.0001. My bad. Because let's see, 1, 2, 3. Yeah. Yeah, that's what I was thinking. Yeah. I was trying to figure out how that calculator convert them, but the calculator treats it as 1 times 10 to the negative 4. So we're starting with a 1, not a 10, okay? All right, y'all. So, whoo, you got to watch Math Lab. That's why I would probably have kept it like the 10 to the negative 4th. All right, y'all. Log base 4 of 5x minus 4 equals 1. Now, after this one, they'll start doing more work. But a single log equal to a number, so we're going to rewrite again. So my base is 4. My exponent is the 1. And 4 to the first is going to equal the 5x minus 4. All right, so 4 to the first is really just a 4. So I get 4 equals 5x minus 4, y'all. So I'm going to add the 4, and then we'll what? Divide by the 5, okay? So we're going to add our 4s. So 4 plus 4 is 8. That's going to equal our 5x. And then let's divide by the 5. So y'all, those cancel. I get our x. Let's see. What's my chat popping up? What do you got? 8/5? Perfect. 8/5 it is, y'all. Can't reduce that. So keep that as an 8/5. So the first few I was able to rewrite as exponential. I had a single log equal to a number. So let's see what happens when I throw 2 logs in here. A log x plus a log of x minus 3 is going to equal 1. So this is what I'm talking about. I got more than one log on the left side of the equals. So I'm going to make this into a single log. So the question is, since these are being added, do I want this single log to be a product or a quotient? Because we'll bring out our log. So how about that? Product or quotient? And y'all, okay, product, perfect. Because remember, we said if they're being added, we write it as a product. So that's going to be a x times x minus 3. Oh, that's going to equal 1. And I think I would do one more step. I would probably actually do the multiplying here so that I get a log, and I'll put it in parentheses now. X times x is x squared. X times negative 3 is negative 3x. All that equals a 1. Now, we got a single log, so we're going to rewrite it at this point. Because I still don't have a log equal to a log to do the log base yet, okay? But they're getting to the point where we're combining logs now. So, y'all. What is my base? Because I'm about to rewrite it as exponential. So what's my base? My base is 10. What's my exponent? So what exponent are y'all about to put on that 10? Okay, that's going to be a 1. So y'all, 10 to the first is going to equal x squared minus 3x. Alrighty, so 10 to the first is 10. So what happens here, since I got an x squared in this, I got to get a 0 on this side and start factoring this, okay? So I'm going to subtract 10 from both sides because we need to get a 0 on one side when you got x squareds in it. So that's going to give me 0 equals x squared minus 3x minus 10. All right, y'all. So to solve this, we're going to factor this. I got an x and an x. Oh, what do we need? Factors of 10. That'll give me a 3. One's going to be positive. One's going to be negative. Let's see. So y'all got that factored. X plus 2. Good job. And x minus 5. Now that it's factored, we got to set each of these factors equal to 0 to get our two answers. So y'all, let's see. On this one, I'm going to subtract 2. X equals negative 2. We'll add 5 on the second one and get x equals a positive 5. So my question is, what is my final answer? Oh, Vinny, you did good. Because remember, I can't take logs of negative numbers. So since that gave me a negative 2, I've only got one answer, and that's going to be that x equals 5. So y'all watch that. Get rid of them negative answers, okay? All right, let me see what we got. So it looks like we're on 14. All right, y'all. Log base 4 x plus 21 minus log 4 x plus 5 equals a log 4 of an x. All righty. We got to make a single log over here, remember? And these are being subtracted, so they're going to look like a quotient. So bring out that log 4. You'll have the x plus 21 on top because it's the positive factor. And then on bottom will be the x minus 5 because it was the negative factor. That's going to equal a log 4 of x. Oh, y'all look at this. I got a log base 4 equal to a log base 4. So I got a log base equal to a log base. So since these log base 4s matched, that means x plus 21 over x plus 5 is going to equal x on the right side. All right, y'all. So this is sort of what the support was showing you. I'm going to make the x look like a fraction by putting a 1 on it. But to solve this kind of equation, you cross multiply this top times that bottom. Well, x plus 21 times 1 is x plus 21. Then you take both of these on this bottom and multiply by that top. So you got an x times x is x squared. And then you got a 5 times x is a 5x. So here I do cross multiply. And you can always make any number or variable look like a fraction by putting a 1 under here, okay? All right, y'all, look here. X squared term. So both of these got to move over here so that I can get a 0. So we're going to subtract x from both sides. We're going to subtract 21 from both sides. I can subtract them both at once, okay? So the x's cancel, the 21's canceled, we're left with a 0. All right, over here, bring down the x squared. 5 minus 1x is 4x. And then that brings down to negative 21 because it ain't got nothing up there to subtract from. Also, look here. We get to factor again. So x squared is the x and the x. So y'all find me my factors of negative 21. So I'm getting a bunch of 7 and 3s. So that looks good to me. Positive 7, negative 3. And you'll know what I'm going to do now. Set them both equal to 0. So y'all here, we'll subtract 7. X equals a negative 7. Here we add 3. X equals positive 3. So final answer. So I'm getting a 3, yeah, because we can't take that negative one. So our only answer is the x equals positive 3. Good job, y'all. All right, here we go. Log base 4 of x plus 1 minus log base 4 of an x. All of that equals a positive 4. So I know I'm not going to get the log base on both sides because that's only a 4. But I do need to combine this into a single log. So we bring out the log 4. Being subtracted, so we're going to write it as a quotient, the x plus 1 on top, the x on bottom, and all that will equal a 4. All right, so we only got a single log equal to a number, so we're going to rewrite this one as exponential. So we have a base here, which is a 4. Exponent is a 4, and that's going to equal x plus 1 over x. All right, y'all, one of y'all punch this in for me. 4 to the 4th. And then that's going to equal to x plus 1 over x. I think that's like 256. So y'all, yeah. So 4 to the 4 is 256. All right, y'all, so you know what I'm about to do, right? I'm going to do what I did here. I'm going to put a 1 under the 256. And I'm going to cross multiply. The 256 times the x is 256x. That's going to equal 1 times the x plus 1, which is x plus 1. So y'all look here, what we got to do is get all these x's on this side. We don't have no x squareds, so we're not looking for a 0. We're just solving it for the x. So let's subtract x from both sides. So 256x minus 1 left me 255x equal to that 1. And then guess what? I'm going to divide both sides by 255. And that'll equal 1 divided by 255. Y'all look at that. Those cancel, leaving my x. Woo, that ain't going to divide. So my final answer will be a 1 over 255. So you're going to get a big fraction like that one on your number 15 too, okay? All right, y'all. So some of these are a little tricky, so just Most of these is just once you get rid of the log stuff, is just getting them set up to how to actually solve those for those x's, okay? All right, so I'm gonna turn my paper over. All righty, so let's see. Two more. 16 says, all right, y'all look here. Log base 2 of an x plus log base 2 of an x minus 1 equals a log base 2 of a 6. So y'all can see I got two logs over here. We got to make that a single log. They're being added, so we'll write it as a product. Log 2 of x times x minus 1 will equal the other side, which is a log 2 of 6. And y'all, let me actually multiply this out real quick, remember, so that I get a log 2, and I'm going to put it in parentheses. X times x is x squared. X times -1 is a negative x. That's going to equal log base 2 of a 6. Oh, so y'all see we do have a log base equal to a log base. Which means x squared minus x equals that 6. So guess what? You got an x squared term. We need a 0 over here. So we're going to subtract 6. Oh, y'all, here we go. That's going to give me what? An x squared minus x minus 6 equals 0. So it's time for y'all to factor. So I know I'm going to have x's here. So y'all factor that 6 down and get me some factors that are going to equal, I guess, what, a -1 on that. All right, I don't know if I'm getting a delay or so I'm not seeing nothing pop up. So y'all, that would be a -3 and a +2. Well, 6 and 1 will give you 7 or 5 because remember we need to get a 1, so we're going to use 3 and 2. You'll have a -3 and a +2. Okay, so remember when the last one's negative, they got unlike signs, and the factors of 6 subtract to get to 1. Okay. All right, y'all, set both of them equal to 0. So I'm going to get a +3 here. Subtract 2 here. Get x is a -2. Y'all, let me show you a trick, though. If you don't like factoring very good on these exercises, let me show you a trick to do. I'm going to go to y equals, because y'all got calculators. I'm going to go to my calculator. I'm going to go to y equals, and I'm actually going to plot that. X squared minus x minus 6. Now, you can graph it. We're looking for x-intercepts. So you look right there. It's crossing at -2 on that side. And on the right side, it's crossing at +3. So that's my two answers. I got 3 and -2. So if you don't like factoring, graph it, okay? And then you can look at the table. Well, where's the y values? So let me go up to that negative. There's -2. It had a y value of 0, right? And then go down here at this +3. It has a y value of 0. So that's telling me that those are the solutions to that equation. But my final answer y'all got up there says x equals 3 because I can't take a negative answer. Oh, so 17 is just like 16, okay? Although they don't have a log on the right side, it's got a log base 2, x plus 2, plus a log base 2, x minus 2. Oh, that's going to equal 5. All right, so I got to get that single log over here. So to do that, bring out that log 2. And then they're being added. So remember, it's a product. X plus 2 times x minus 2. All that will equal that 5. And y'all guess what? I'm going to multiply those real quick. Now, these are conjugate pairs, so I'm going to shortcut. I'm going to do the x times x and get an x squared. And then 2 times negative 2 is a negative 4. All that equal to 5. Remember, you don't have to FOIL everything when they're conjugate pairs. So let me write that under there. Conjugate pairs. Because when they're conjugate pairs, the middle stuff cancels every time anyway. So shortcut it and be done. Now rewrite it. Oh, my base is a 2. My exponent is a 5. And that's going to equal x squared minus 4. Whoa, y'all, 2 to the 5th. What's that? 2 times 2 times 2 times 2 times 2 should give us 32 equals x squared minus 4. Now, what I like about this one is since I don't have an x term like I did over here, I just got an x squared in numbers. I'm going to get the x squared by itself and do the square root stuff. So I'm going to add 4 to both sides. 36 equals x squared. Then we're going to square root both sides. Now remember, the square root's a positive and a negative, right? We've always put a plus or minus in front of our square root. So that I get a plus or minus square root of 36, which is 6, equal to my x. But guess what? I'm not taking both of those answers. What do you got? VD, it's it. X equals 6. My only answer. So on this one, when you do the square roots, you really don't need the plus or minus when you're looking at logarithm equations, okay? Since we're only taking the positive answers anyway. So y'all, guess what? That was 9.6, solving equations. Now, for the support, I'm going to do one or two. I'm going to do one to show you. But they got 3 problems doing that cross multiplying stuff. So this one says solve x minus 8 over x plus 3 is going to equal 1 over 2. So guess what? Everything on this top multiplies by that 2. So 2 times x is 2x. 2 times negative 8 is negative 16. That's going to equal both of these times that top. So the first 3 of these you're going to cross multiply. All right, so y'all let me get the other side. X times 1 is x. 3 times 1 is 3. Cross multiplying gets rid of all the fractions. Now we just solve it. So I think I'm going to move my x over here by subtracting it. So y'all, 2x's minus 1x is x minus 16 equals 3. And y'all, to finish that, I'm going to add 16 to both sides. And my x equals 19. Okay, so the first three, that's all you're doing, cross multiplying. Everything on one top times everything on the other bottom, and vice versa. Now, number 4, I won't do it, but they want you to solve on number 4. So number 4, you're going to either factor or graph to get the solutions. Okay. So that would be number 4. You're just going to graph it or factor it to get your two solutions because it's got a v squared in it, okay? And then number 5, on number 5, it says solve by factoring. So I'm going to show you how I would do number 5 because it's got a number in front of the x squared, okay? So this is a 5x squared minus 7x minus 12 equals 0. So I wanted to show you how I do the ones when they got the number in front because we ain't really done many of these. So what I do on this one, I got to multiply the 5 times 12. That is a 60. Now, I don't even care about the sign, y'all. I just want that 60. So 60 is the number I find factors of. That'll subtract and give me 7. Okay? So since the number's in front, you got to multiply first before you find your factors. So 60 would be 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. One of those will subtract and give me a 7. So remember, I'm still going to put an x in front of both of these. The last number's negative, so you got unlike signs. And we want factors of 60. That gave me 7 over here. Well, y'all, that's going to be 5 and 12. Well, let me show you what I'm going to do with that 5. I borrowed it for a second to get to 60. So let's see. Since the middle is negative, the larger number 12 is negative, and the 5 will be positive. Now, instead of kick it out, once I got the two factors, I got to divide both of these by that 5. So you borrow the 5 to get the last number, and then you divide that 5 back out, okay? So let's see what that'll give me. This one, 5 over 5, will make that an x plus 1. This one I can't simplify, so that's going to stay x minus 12 over 5. But y'all, guess what? Set both of these equal to 0 and solve it. And y'all, are you realizing that when you're solving it, ain't we just changing the sign of those factors? Look, this one was positive 1. The answer became a negative 1. I'm wanting y'all to learn that, if nothing else this year, that these solutions always have opposite signs than the factors, okay? And here, I'm just going to add 12/5 to both sides. I don't mind adding fractions when they're adding to a 0, okay? So bring down that x, and that's going to equal a 12 over 5. Okay? So if you got a number in front, that's what you got to do. You got to multiply it by the last number, get factors of that number that equal the middle. When you got them two numbers, divide that 5 back out, okay? All right, y'all, so that is the 9/6. So, what missing page? Let me see. So you are going to play with that. 9.7 on Monday or Tuesday, I mean, is fairly short. So 9.7 short. So what I'm going to do, if you got any questions over this log stuff, Monday, we can get that fixed for sure. So I want y'all to try these over the weekend until then, till Tuesday. But we'll have a lot of time Tuesday to sort of play with stuff. Okay. So I'm going to stop my share. And let's see, 7:21. So I'm going to quit my video.